Hello friends, in this video we are going to estimate the Km and Vmax. So let's discuss the basic concept. So when a drug is metabolized inside the body, which is known as in vivo, especially through enzyme pathways, it does not always follow simple first order kinetics. Okay. So in such cases, we use Michaelis-Menten. Okay, Michaelis-Menten kinetics we use. So that's where we estimate Km and Vmax. Km is Michaelis constant and Vmax is the maximum rate of metabolism. Both are important to decide the correct dosing rate for a patient. And also we assume that our body, the whole body acts as like one compartment only, like single compartment model, and steady state conditions also we assume, which is known as rate of drug input will be equal to the rate of drug elimination or output. And the basic formula here is dr equals to Vmax into Css divided by Km plus Css, where dr is the dosing rate and Css is the steady state plasma concentration. You know that Km is Michaelis constant and Vmax is the maximum rate of metabolism. So let's discuss the methods for estimation of Km and Vmax. I want to tell you that in this video we are including three methods. We are going to see only three methods. First one is Lineweaver-Burk Plot method, second one is Hanes-Woolf method, and the last one will be the direct estimation method. Let's see the Lineweaver-Burk Plot method. So it is also known as double reciprocal plot. So how it will be calculated, let's see here. Firstly, we have to take the dr dosing rate formula, which is equals to Vmax into Css divided by Km plus Css. I think you already got this. To this formula, we have to take the reciprocal on the both hand sides. Okay, so reciprocal means 1 by dr. Okay, then equals to Vmax into C will goes to the denominator, and Km we are separating Km and Css. So first we will take the Km only. So on the left hand, on the here we are taking Km. Okay, so and Css will be get cancelled out. Okay, Vmax will be here, Css will be get cancelled out. Okay, then we have to plot the graph. So on y-axis you have to take 1 by dr, and on the x-axis you have to take 1 by Css. So our graph outcome will be slope equals to Km divided by Vmax, and y-intercept will be the 1 by Vmax as it is in the form of y equals to mx plus c. So c and m and x and y values are here. Our second method is Hanes-Woolf Plot. So in this method also we have to take from starting our equation will be the dr equals to Vmax into Css divided by Km plus Css. After that we have to multiply this Km plus Css on both hand side. Okay, this is the first step. So on dr we are on left hand side we are multiplying Km plus Css, and on the right hand side also we are multiplying Km plus Css. So this Km will be get cancelled. Only we are left out with Vmax into Css. Hope you got this. After that I am just expanding this, okay, dr into Km and dr into CSS, okay, plus sign will be as it is, equals to Vmax CSS. After that step, we have to rearrange this, okay. Km will be here on the left hand side only, on the right hand side it goes what dr into CSS will go on the right hand side. So here it is in plus, when it goes to the other hand side it will become in minus sign, okay. So after that, this step we are taking the common CSS, okay. After taking CSS, our equation becomes dr Km equals to CSS into Vmax minus dr, okay. We are taking common CSS. Second step will be the dividing both sides by dr. So both left hand and right hand side we are dividing with dr, okay. So dr Km divided by dr equals to CSS in brackets Vmax minus dr divided by dr. So this dr get cancelled. We are on the left hand side only Km remains. On the right hand side we are, this will get cancelled out. So assuming that here will be the 1, okay, this is get cancelled out, so 1 will be there and Vmax dr will be there only. So our last equation will be the Km equals to CSS Vmax divided by dr minus 1. Then our third step will be the divide the both hand sides by Vmax, okay. Firstly we have multiplied with Km plus CSS, then uh, then second step will be the uh, dividing both sides with dr, and the third step will be the dividing both hand side will be the Vmax, and our equation becomes Km divided by Vmax equals to CSS divided by uh, dr minus CSS divided by Vmax, okay. This Vmax and this Vmax get cancelled. So after that we are substituting, we are rearranging this equation, okay. Here it is remaining here only, okay. This will go to the other hand side, okay. So here it is in minus, so when it goes to the other hand side it will become plus. Now this is in the form of y equals to mx plus c. So our slope will be the 1 by Vmax and y-intercept will be the Km divided by Vmax. So the third method is the direct substitution method. Here you have to give two doses to the patient, that is dr1 and dr2, and after that you have to measure CSS1 and CSS2, okay. So by these values you can measure Km and Vmax. To measure Km you have the formula which is followed as dr2 minus dr1 multiplied with CSS1 and CSS2 divided by CSS2 minus CSS1. Then Vmax formula will be the dr1 in multiplied with Km plus CSS1 divided by CSS1, okay. So why we use this method? Because it's a shortcut method, no need for the graph. It works very well for quick calculations. And note that for curvilinear CSS versus dr plot, it will be observation only, okay. If you directly plot CSS on y-axis versus uh, dr on x-axis, you will notice at low doses, okay, at low doses linear relationship will be there. At high doses curve upward will be there, okay. So reason will be the because of metabolism is capacity limited, okay. Capacity limited is the metabolism, so non-linear kinetics when the enzyme is saturated. This plot is only for observation, not for exact Km and Vmax. And that completes today's explanation of how to estimate Km and Vmax using in vivo methods in biopharmaceutics and pharmacokinetics. If you like this easy step-by-step breakdown, make sure to write these notes in your book and practice daily. If you found this video helpful, don't forget to like, share and subscribe. Thank you for learning with me. See you in the next session.